The last two functions to add to this class are the save game and load game functions, which, like the spawn cube functions, will be exec functions, meaning that they can be called from the Unreal console. The save game function can be called to save the game. The load game function can be called to load a previously saved game. I'm going to start by coding the save game function. I'm going to code that beneath the spawn cube function. I'm going to type function exec, make sure we specify exec there, save game. And I'm going to simply call the game current state save function, passing it a parameter, a path, save object. I'm going to be saving it to, I don't know, let's say this path, saves save game.bin for binary. Be sure when you're specifying paths to use the double backslash prior to folder and file names. A single backslash will not work correctly. And that's the complete save game function, and there really isn't much to that. It simply calls the save object function for the game state object. The next function I'm going to create is the load game function, and this one has a little bit more to it, and I will explain why very shortly. Load game. Let's create the load game function. Now, when we call the load game function to load a game from a saved game file, it will load up the game objects array in the game state object. That is, it will populate the array in that object with all the cubes that were in the level. That is, it will populate that array with all the locations of the cubes in the level. But loading that array will not in and of itself create the cube objects in the level. It merely populates the array with their locations. It is still down to us, when we load a game, to respawn the cubes in the level and to set them to their saved locations. And for this reason, the load game function must be sure to do that. It must be sure to load the information back into the game state object, and then to cycle through that array, and for each element in the array to respawn the cube back into the level. And so we're going to do that now. I'm going to start coding the load game function by calling the load object on the game state, by calling the load function on the game state object. I'm going to type game current state dot load object, and I'm going to specify the path to which I saved the game, save game dot bin. You don't have to choose this path. You can choose your own path. You can provide the gamer with an interface where they can enter their own path. I'm just using this path for the purposes of example. Now, once I've loaded the game state object, what this will do is it will populate the game objects array of the game current state object, and that array contains information about the location of all the cubes in the level. But note that this function, calling load object, will not spawn the cubes back into the level. The level, when it begins, will begin empty, and this function on its own will not spawn the cubes back. We must do that manually. In effect, we know that we need to spawn as many cubes into the level as there are elements in the array, because that is the array on the game state object. We know that if that array contains 10 elements, 10 location values, then we must spawn 10 cubes. one for each element of the array. Now, to do that manually, we are going to have to loop through each and every item of the array in the GameState object. So I'm going to type for each for a for each loop. I'm going to type game current state dot game object. That will create an array that will loop through each and every item of the array. Now, there is, however, one further step we must add to this to make this statement complete. This array, this parenthesis here, is empty, and we're going to need to add an object in there. Now, the object that we're going to add in here is going to be an instance of the game state structure that we use in the array. Let me just go over to the game state file here, and we can see that we've got our structure that we declared earlier. We're going to be using an instance of this in the function that we are creating. Let me just copy the name here and switch back to the GameInfo class here. I'm going to move down to this statement, and in this parenthesis, at the top of this function, I'm going to add a local variable, which I'm going to call, let's say GeoStruct for game object struct. I'm going to put this into the parenthesis here. Now, what will happen is on each and every iteration of this loop, this GeoStruct will be assigned, or will be a reference to the current item in the loop, so that we can access the current item. But there is a problem with this code. And the problem in particular is that this game object struct that we declared in the game state file is not accessible to this game info class, which is a separate and independent class. The game info class does not know about this game object struct. We must tell it about this structure, and the way we can do that is by moving back to the top here to the custom class declaration and adding the statement depends on, and in parentheses we put game state. If you omit this specifier, this function down here, the load game function, will not necessarily recognize this game object struct object. It won't know that it exists. You must therefore be sure to put this depends on game state specifier. That way, this class, this custom game info class, will know about the structures and the enumerations that we declared in the game state class, and it will be able to use them as objects, as those structures and those enumerations were declared in this class. So, having made that clear, let us now complete the rest of this load game function. There's only one line remaining now for us to code in this load game function, and it is this line. I'm going to select go struct dot reference, the pointer or the reference to the cube that we're going to spawn, equals spawn class cube memory. We're going to skip some of these optional parameters and go struct location. And with that in mind, that now completes our load game function. Not only that, but it also completes our game info class. And with these three classes now completed, we are ready to compile all of this code and to move straight over into the UDK editor and test out our exec functions, our spawn cube function, our save game function, and our load game function. So let's go and give these a try. Now, having created our 3 classes for this project and having compiled them, I have started the UDK editor and I have loaded the map that I have created. Now, this map and the code for this tutorial are all available for download at the URL specified in the notes for this video. Now, before we get started at testing our level, make sure that the game info class for this level has been specified. To do that, click on the View menu here at the top of the UDK editor and select World Properties. From the World Properties menu, select Game Type, not Zone Info, Game Type, and make sure that the game type selected here is Custom Game Info, or whatever you have named your game info class if you are following along and using your own names. With that in mind, press the Play in Editor button from the toolbar or press Alt F8 on the keyboard. And let's generate some cubes here. This time, instead of generating 3 cubes, let's generate just 2 cubes. So I'm going to spawn a cube with the spawn cube function. I'm going to specify 297,350, -330, and we have 1 cube. And I'm going to spawn the next cube, spawn cube -63, 350, and 17. And there we have the second cube. I'm going to save this level here, save game, using the Unreal console. And then I'm going to exit the level by pressing the escape key on the keyboard. Now it's time for us to restart the level and see if we can load it back to get it just as it was before. So we'll press play again. Going to open the console again, pressing the tab on the keyboard and choosing load game and then pressing enter. And we'll see that we have our 2 cubes pop back into the level just where we saved them. Now, of course, the load and save functionality that I have coded in this level is not perfect. There are ways in which it could be improved. Perhaps there's a better class design. Perhaps you could arrange your data better. But the important thing to keep in mind is that this tutorial is intended to show you the basics. It's intended to show you how you might go about implementing a load and saving framework. And I hope you have found this tutorial useful. Thank you for watching.